Hello and welcome back to another episode of Math with Sohn. Today we're going to be looking at displacement, which is position graphs. We are going to be looking at velocity and acceleration graphs. And you really need to be able to go from one to the other and back and forth, okay? So the main thing you got to be really looking for is what is constant? Let's say we have a constant velocity of 3 meters per second. So if you have a constant velocity of 3 meters per second or speed of 3 meters per second, that would probably be the graph you would like to start with. So if this is our velocity graph, and I'm putting it in the middle because, it's kind of in between displacement and acceleration for a reason. This is position, this is speed, velocity, and then acceleration is how quickly you are speeding up over time. So I'm putting velocity in the middle for a reason. So if we were having a velocity that is constant at 3 meters per second, let's say for, 4 seconds. 1 second, we're going 3 meters per second. 2 seconds, we're still going 3 meters per second. 3 seconds, we're still going 3 meters per second. And 4 seconds later, we are still going 3 meters per second. So anytime you see the word constant, that would indicate that it is going flat, zero slope, not doing anything. However, the displacement or the position graph, how far you have gone, the displacement and or position graph, that one will be changing because you may have started with a position of 0, but then after 1 second has gone, you had a speed of 3 meters per second. Make sure you are labeling your axes either as velocity, meters per second, and seconds or time for the time interval. This would actually be just meters. So after 1 second has passed, we were going 3 meters per second. That means I will have gone 3 meters. But then after 2 seconds, I will have gone an additional 3 meters, and so on and so forth. 3 seconds, I will have gone 9, and I'm not going to have enough room to write the 4. But you can kind of tell that it is going to have this upward sloping line if this continued forever, assuming there is no friction. So the position graph is going to be the slope of the constant velocity. Well, I kind of said that backwards. So whatever the constant velocity is the slope of your position and or displacement graph. Now let's talk about the acceleration graph. Acceleration graph, in this case, is going to be 0 because we are not increasing in speed at all. We started at 3 meters per second, we ended at 3 meters per second, and acceleration is how quickly you are moving, how much faster you are becoming. And we have not become any faster. We have stayed at 3 meters per second. So it is not accelerating nor decelerating, so it would be stuck at 0 for that entire interval of 4 seconds. Okay? So that's the basic introduction. The next problem we're going to be dealing with will have acceleration, and we'll be able to see all three in action. Okay? So let's say that for our next one, we have a constant acceleration of 1 meter per second squared. Okay, so if we have a constant acceleration, that means that we are increasing in speed over and over and over again. We're going to continually get faster. For that first second, we'll only be going 1 meter per second. And then the next second, we're going to go even faster. And even faster. It's going to keep getting faster and faster and faster, which means some things are going to occur. Okay, so let's start with the acceleration graph. The acceleration graph will be a constant 1 meter per second squared over the course of, let's do 3 seconds, because it looks like I couldn't fit in 4 the last time. So this is going to be a perfectly horizontal line for the acceleration, but the velocity is not going to be, because the velocity is how quickly we are actually moving over the time. And, well, on that first second, we were going, 1 meter per second, but then we're constantly increasing our speed at 1 meter per second over and over and over again. So like after 2 seconds, I will have gone an additional 1 meter per second. So in this case, the slope will be 1 over 1 over and over again for that entire interval of 3 seconds, which tells you something. Anytime you are going from acceleration to velocity, if you have a constant acceleration, your velocity would be the slope of that constant acceleration. Similar to when we went from velocity to position, it's the exact same thing. If you have a constant velocity, then your position would have been the slope there. Anytime you're moving to the left or upward, if you're thinking in terms of calculus, because when I was doing this for calculus, it was displacement, then velocity, then acceleration. They were kind of like lined up on top of each other, whether you were integrating or deriving, which also tells you that if we have to find the position graph, which is beyond the scope of AP Physics 1, but it is not completely beyond it. If you are going faster and faster and faster, you started with an initial velocity of 0, and then after 1 second, you're kind of moseying around. But then after 2 seconds, you're going to increase in speed, so it's going to have to curve upward. And after 3 seconds, you've increased in speed again. It's going to curve upward again. It's going to continually have this curvature indicating that it is going faster and faster and faster. And the actual equation for this would be y equals 1/2 x squared, which makes sense because when we dealt with our kinematic equations, you noticed that 1/2 at squared, which was 1/2 the acceleration times time squared, so on and so forth. But this would be meters, and this would be seconds, and that would be the end of this video. Until next time, everybody, stay positive. On the next video, we're going to be going over position versus time graphs specifically and how we can actually learn all the aspects of that. All right, I will see you all in the next one. Bye.